Yeah, thanks for staying with us here in the second day. I hope we can make good progress on this conference too. So, Dryad, we're about wildfires, ultra-early detection of wildfires, and we want to help stop them, those fires, because they have a huge impact, a negative impact. And it's not good to start with a negative message, but it is a very negative message. Wildfires are everywhere, and they're growing dramatically. What most people don't know is they cause about 20% of global CO2 emissions. That means between 6 and 8 billion tons of CO2 are being emitted from wildfires each year. That's about the same amount the entire traffic puts into the air. And we're investing billions into electrification of traffic, and that is the right thing to do. But we seem to be ignoring the other 20% of the problem. And that's something which we think is a low-hanging fruit. We need to do something about it also because it has a huge effect on biodiversity. We're all talking about climate change as the biggest threat to humanity, and it's probably true, but biodiversity loss is even worse. If we lose biodiversity, we lose our ability to be sustained on this planet as a species. And we're losing about 3 billion animals in fires each year. And of course, the habitat, the forest is gone after a big fire. And now, there are also 140 billion plus financial damages caused by those fires. Loss of business, loss of property is one of them. And the good news is that 80%, in Europe it's even 85%, are human-induced. So we are the problem. It's arson, it's reckless behavior, it's technical faults, it's accidents. That's what's causing it. It's us causing most of the problem, so it also should be us stopping it. And we would like to help with that. We'd like to help with what we call ultra-early detection of wildfires, because we think if we can cut down the time it takes to respond to a fire, we should also be able to eliminate much of the problem. And of course, there are many companies and solutions being thrown at it. And the more, the better. We need all of them. We need the satellites that have a great overview of the fires, and they can track where the fire is going. They're not particularly good at detecting fires because they either have a long revisit time of several hours or the resolution is not good enough. Cameras are a bit better because they're closer to the action, and they can actually detect fires by looking at smoke plumes rising above the tree canopy. But that also means you need to have a fire that's hot enough to drive the smoke up into the air so that it can be visually detected. Now, we've taken a different approach with Dryad, which we think is complementary to those satellites and cameras already in the market. We want to detect fires during the smoldering phase, during the first hours after someone throws a cigarette. That's when we want to detect it, when the fire is really small and therefore easy to extinguish. And that's why we say here, time is really of the essence. If we can tell the fire brigades about a fire that's about to develop, they can just send a fire truck or a helicopter and the fire is done. If you wait 2-3 hours later, the tree crowns are on fire, and you may be on your way to a mega fire that's difficult or impossible to stop at all. So it's really about time. So we've developed this product and solution suite called SilverNet. Silver is Latin for forest, and net is the network. So we're basically building a network in the forest, and then sensors that actually help to detect fires earlier than anything else on the market. The sensor is a solar-powered gas sensor. And it's not a particle sensor. It doesn't look at CO2. It looks at gas, hydrogen, carbon monoxide, VOCs. And it's using built-in machine learning in the sensor to detect the pattern of gas that's typical for a fire. We do the data processing on the edge in the device because we don't have the bandwidth to transmit all the data to the cloud and process it there. So it's actually in the sensor itself. It's solar-powered, no batteries. We have super cups for energy storage to make through the night. And then we do work in the shade, in case somebody is asking that question, which of course everybody wants to know. We do work in the tree, under the canopy, in the shade. It's hard, it's damn hard because there's very little energy, but we made that work. And of course, we use LoRaWAN, for communication. So the sensor does have a built-in LoRaWAN radio, and it's a standard Class A device, sleeps all day, measures once per minute the gas, and if it detects the gas, it immediately sends an alarm, of course. And it does that over a network that we've built specifically for the forest. So we built our own gateways, a combination of what we call border gateway and mesh gateway. The border gateway is a gateway that's connected to 4G, LTE, narrowband IoT, LTE-M with GPRS fallback. And that's good for connecting to the internet, like many other gateways do. The difference here is solar powered, so we deliver solar panels with it out of the box. But what's more important than the border gateway is the mesh gateway. That has a built-in solar panel, and it's basically a range extender, but not a single hop, it's a multi-hop. So we can support easily 10, 15 hops in the mesh network, and we extend the range of the LoRa gateway hop by hop by hop. And why is that important? You know, LoRaWAN has a great range, or LoRa, I should say, 8, 9, 10, 20 kilometers easily, unless you are in the forest. Because the forest is full of trees, right? And trees are full of water, and water absorbs radio waves. So you basically can say bye-bye to your 8, 10 kilometer range and hello to 1, maximum 2. And that's why we need those mesh gateways, because we're extending the range deeper and deeper into the forest with that mesh. And of course, yes, that's what we've done with our own gateways. We then relay the information to our cloud platform, where we do monitoring, device management, remote firmware updates to update the firmware model, the machine learning model in the sensor over the air, over LoRa. So it's an end-to-end solution, but really the key is this mesh. Because without the mesh, we wouldn't be able to penetrate the depth of the forest, and the forest is huge. We can do a small demo with just the gateway and our sensors. But if you wanted to deliver really large deployments, which it has to be by definition, we would need the mesh in order to extend the range into the depth. How many sensors do we need? Well, the more the better, and we will need a lot. We'd say about an average of one sensor for 5 hectares, so 0.2 sensors per hectare. Dense deployments along roads, pathways, around camping sites, you'd need 1 sensor per hectare. And in very remote locations, you just put 0.1 sensors per hectare on average. So we still need a lot. Now that we have a network in the forest, what about if we do more with that? And now we're talking about where we want to go next. We want to become the AT&T of the forest. We want to be the network infrastructure for the natural world, and then put all the applications and welcome all the sensors that are LoRaWAN compliant into our network. So we're looking at fuel moisture, subflow, soil moisture, chainsaw detection, pagers for forest workers, or tree growth sensors. We want to be the digital backbone of the natural world, and in particular, the forest. Now, that's the vision where we want to go. But really, we are an impact for profit. The impact is the mission of the business of Dryad. But we need to do that profitably so that we can scale, and scale faster and have more impact. But our business plan, of course, says we will be profitable, we'll sell a lot of sensors. Our target is to sell and install 120 million sensors by 2030. That's our ambitious business plan. And why is it so ambitious? Because we want to have the impact. If we are able to achieve that volume, we would be able to prevent 3.9 million hectares of forest from burning. And that would save 1.7 billion tons of CO2 emission, and having a real meaningful impact on climate change and biodiversity loss, which is definitely what we are aiming for on the impact side. But of course, also making a lot of business along the way. And I'd like to thank you for listening, but not let you go without one figure that you might want to keep in mind. You've all seen the fires in Canada this year, and one figure that I read the other day really struck me. They lost 14 million hectares of forest in one summer. Now, I'm from Germany, and we claim to have a lot of forest. The entire country of Germany has 11 million hectares of forest. So the Canadians lost more than the entire German forest in one summer. Let's stop that, and thank you for it.
Thank you very much, Carsten, for your presentation, but I think also for the work you do. It's certainly a meaningful application of LoRaWAN and IoT, so we're very happy to have you here. Yeah, and I think from a technical perspective, you say all the right words to an audience: firmware over-the-air updates, mesh. Like these are interesting applications. But you've mentioned mesh. We have relay now being a topic also here at the conference. With your mesh application, are you LoRaWAN compliant, or are you half a step next to that standard?
That's a very good question, and I think the relay is a good idea to extend the range of a gateway, but it's single hop. So, and it's limited in the number of sensors. We've implemented the multi-hop mesh between our border gateway and the mesh gateway. We can do 10, 15 hops and therefore extend much larger range. But then you're right, the question is that actually compatible? Well, what we do internally between the gateways is non-standard. That's proprietary. We're using LoRa as a transport, but we put a proprietary mesh protocol on top of that because LoRaWAN, unfortunately, so far does not have support for mesh. But to the outside, that means to the sensors on one hand, and towards the network server, and we of course use the Things network server, as we should, TTI, and that is fully standardized. So we can support any Class A, Class B, Class C device without requiring any change in the firmware of the device. Unlike the relay, for example, that does require an update, we do not. We can take any standard Class A device and use it in our network. And we can work with an unmodified TTI stack on the network side. So it is transparent and standard compliant to LoRaWAN to the outside, but proprietary inside.
Awesome. Yeah, I can see you invested a lot of effort in finding the sweet spot between being compliant and plugged into an ecosystem which has been growing over years, while making sure that your solution performs at its best and is, can make a huge impact by 2030, hopefully. Thank you very much. Does anybody from the audience have some questions for Carsten? Yes? Any blind spots? Okay, so the question was at the sensor density, you were mentioning, are there any blind spots which you tolerate, let's say, in your deployment?
Well, when we deploy the sensors, of course, the sensors need to smell the fire. So the gas has to hit the sensor. If the gas goes in that direction, the sensor is here, has a blind spot. But how we address that is simply by mass. So deploy a lot of sensors, not just one line. If you deploy a checkerboard of sensors, there will always be a sensor in one direction where the wind will take the gas. So sooner or later, a sensor will be hit. It does require, though, a lot of those sensors, which is why the price point of the sensor itself is extremely important. And we've designed the system so, from a manufacturing perspective and architecture perspective, that we can really go low cost. So we're sub 100 euro on the device price, even if you just buy a single one, because we know we'll need a lot of those sensors in the field.
Great, thank you. Did that answer the question? Yeah, perfect. All right, are there any other questions? Yeah, please.
If you have so much sensors, how do you locate the sensors? Do they have their own GPS, or do you, when you install them, detect which sensor is where? Or
Yeah. Let me just repeat the question quickly for the recording as well and for everyone. So the question was, how do you do device management? If you deploy a sensor, how do you know which the sensor is where? So do you have a GPS tag, or how does the device management work?
Yeah, the sensor doesn't have a GPS tag because that would drive up the price, the BOM, and the price is key. But what we have is a QR code. So when the person installing the sensor, we have a mobile application, and when it is installed on the tree, they take a picture of the QR code, we record the geolocation of the mobile device, we translate that, we sync that back to the cloud, and we record the geolocation where it was installed. And then we assume the trees don't move, so they stay where they are. So yes, we know where the sensors are, but not with GPS.
Right, so if you find them in the forest, please leave the sensor where they are.
Please do so. It's not a tracker.
Yeah.
So
All right, thank you. Any further questions? Yeah, please.
In forestry harvesting, how do you collect the sensors back?
Great. So the question was, if there is any forestry commercially, trees might be harvested and might be cut. Do you collect them back, or how do you deal with that issue?
yeah, of course you can collect them. They're installed typically using a wooden nail at about 3 meters height. We know exactly where they are, so if it's installed in an area which will be harvested at one point in time, you send forest workers into the field with the exact geo-coordinates and a mobile application, and they can collect the sensors and redeploy them in a different field. That's possible, yes.
All right, thank you. Any further questions? Yes? All right, the question was, from a business perspective, who is paying the bill for that?
Yeah, well, our customers are communities. Basically, then we have the state that controls federal land, and we have private forestry as target customers, as well as utility companies, in particular power line companies and railroad, that are facing a huge liability issue in case their infrastructure is causing a fire. So these are the ones actually eventually paying the bill. Benefiting from it are the fire departments. They're not typically the ones buying our product, but it's municipalities, federal, private forestry, and utilities.
Thank you.
Okay.
Any further questions? If not, then yeah, I would like to thank you, Carsten. We're looking forward to your update next year here, how many of these millions of sensors you've been deploying.
Thank you.
Yeah, thank you very much, and let's give Carsten another round of applause. Thank you.